Hello and welcome to our Unit 1, Outcome 7, College Algebra Notes. So we're moving right along. Here we're in Outcome 7 now, so we're more than halfway past through our Outcome 1, or Unit 1 notes. So in this section, we're going to kind of dive a little bit deeper into functions. We already introduced functions. We talked about linear functions. So, functions is something we've talked about for a little bit. But in this section, we want to talk about some of the properties functions can have. So we'll talk about, intervals, or the increasing, decreasing, maybe constant, and then also talk about relative maxima. And then we also want to introduce a special kind of function called a piecewise function, which we'll get into more later. So first off, we're going to do these properties. First one we're going to deal with is these intervals where a function is increasing or decreasing. So when we have straight lines, without any curve to them, when they're just a flat straight line, we look at whether they go up and down as you go to the right. So they could go up to the right or down to the right. And we think about slope, right? We said if they're going up to the right, it's positive slope. If they're going down to the right, it's negative slope. But slope, when you're dealing with these curves, like these, that are not straight lines, slope gets a little weird to talk about because the slope changes as the line curves, right? It's steeper and then it gets flatter, or it's, not as flat and then it gets steeper over time. So the slope itself changes, but despite the fact that the slope changes, we can still talk about whether it's kind of going up to the right or going down to the right. And so we call that increasing, decreasing. If it just stays horizontal, we'll call that constant. So for functions that are not straight lines, instead of dealing with slope, we're going to think of it like slope. Instead, though, we're going to deal with, as you go to the right, is it increasing? So it's going up to the right, then that's going to be, kind of like positive slope is increasing. If it goes down to the right, so as you go to the right, it goes down, that's going to be like negative slope. Well, we'll think of that as decreasing. And if it just stays the same, if it stays horizontal, like zero slope, then we'll call that constant. So we have this, and we call this constant. And so it's important to know with a function what it's doing. If you think about functions that describe like profits for a company, the company wants to know, is the function going to show that they're going up and their profits are increasing, or is it going down and their profits are decreasing, or is it staying relatively the same? Is it staying constant? Any kind of function, you want to know what's going to happen. The output, the result, is it getting higher or getting lower, or is it staying the same? Because what's happening really is important for using the function. Now, when we work with functions like this, when we think about these intervals of increasing, decreasing, or constant, we're only going to work with what we call open intervals. So open is a big word right here. Open intervals means that I'm not looking at just one specific point. I'm going to look at a range of values. If you look at like a single point, if you just try and look and cover up and say, okay, I'm going to look at just this one little tiny point right there and say, at that point, don't look at the intervals, just look at the one single point. Is it going up? Is it going down? Is it staying constant? What is it doing? And the answer is, it doesn't make sense to ask that question. A single point, you have like one dot, it can't be going up or down or constant because it's not going anywhere. It's just a single dot. You can only talk about increase or decrease or constant when you look at a range of values. So we're going to deal with open intervals, and that means we're never going to be looking at the ends. We're not going to look at the ends of the numbers and say, what happens at the end? No, we're going to just say, what happens in the range between them. So open intervals is a fancy way of telling us that this means we're only going to be using parentheses. We're never going to use brackets when we're looking at increasing or decreasing. We're only going to use parentheses because you can't talk about really what happens at the ends of this function. You can only talk about what's happening in the range in the middle between values. That's the only thing we can really talk about. So open intervals, we're going to use parentheses. And then we're not going to talk about the height so much as we're going to talk about where it happens in the x's. So I'm going to say this function is increasing from this x value to that x value, or it's decreasing from this x value to that value, or it's constant from this x value to that x value. So we're going to talk about where it's increasing or decreasing, and we're going to only use parentheses and use x values. These are two things people really mess up on the test. As I'll try and use the y values, they'll give me the height, the tops. I'm like, nope, when we're talking about increasing, decreasing, so when we see increasing, decreasing, constant, we only want the x values. We want to know where it's happening, not what the height is, and we're only going to use parentheses to describe it. So let's look at an example down here, and this will make more sense when I do an example. So first off, let's look at increasing. So where is this function increasing? Now, it's increasing Anytime it goes up to the right. Now, I think most of you probably see this one right here and say, oh, that's increasing right there. And you're right. This piece right here is increasing. You can see it starts, so this is my 0, and over here this is at 3. Now, I'm not looking at the height, I'm looking at how far over it is, 3. So it starts at 3, and it goes, and this arrow says it goes on forever, so it's going to infinity. So it's increasing from 3 to infinity. So that's where it's increasing. So this place is going up to the right, it's going up to the right like this. It's going from 3 to infinity. To the right, it just keeps going. And so it's parentheses, we always do parentheses for infinity, and it's parentheses here because, again, like I said, we always use parentheses. We're doing these open intervals like increasing, decreasing. You can't talk about this one single point and say, yeah, right there at that point at the bottom, this one little point, it's increasing. No, you can't talk about that. You can talk about between these 2 points, 3 and forever, it is going up as you go to the right, but you can't talk about what's happening at this one specific value. So we'll always use parentheses. There's actually a second part where it's increasing. It's also increasing right here. Now I got people that get tricked all the time because they see this arrow and they think, oh, the arrow's pointing down. It means it's decreasing. No, no, no. It's not decreasing. This arrow doesn't tell you anything about whether it's going up or down. It just tells you that it's going on forever and never stops. They just want you to know this line just keeps going. It doesn't stop here. So that's why this piece is still increasing, because as you look, it goes up as you go to the right. The same thing this is doing. Think about it as positive slope. If you go from left to right, it's positive. So the other interval is the interval from negative infinity, because it goes on forever. That's what the arrow's for, until you hit 1, because 1 is where this stops. Again, I'm not looking at the height one, I'm looking at the how far over 1. So from negative infinity to 1, it looks like an 8, but it's negative infinity to 1. That's the other piece. Since there's 2 pieces like this, we use that union symbol we've used a few times now, and that just puts those 2 sets together. So that whole set is the, this stuff that's increasing for us. Okay, let's look at decreasing. We'll do decreasing in red. So decreasing, where is it going down? Well, it's going down to this piece right here, right? This is going down. You see it's going down as you go to the right. That's the piece where it's decreasing. Again, I'm not going to look at the heights. Look at where it happens horizontally. It goes from 2 to 3. It's decreasing. So from 2 to 3, it's going down. And again, always parentheses. I don't care if you reach the values, because that's not important when you're doing these increasing, decreasing stuff. You just want to know that between 2 and 3, this range of values is getting smaller as you move to the right. Okay, last one we have, look at where it's constant. So constant, again, is where it's just staying level. It's just not going up, it's not going down, it's just horizontal. So this little middle piece right here, you can see that that is the constant piece, because as you go to the right, it's just staying the same height. It's not going up, it's not going down, it's just staying horizontal. And that happens from 1 to 2. Again, we're looking at horizontal. I'm not looking up here. I'm just doing 1 to 2. I'm not giving points. These aren't points. These are actually a range of values. This is a range, basically, or how far from left to right. That's what this is. So that's from 1 to 2. And again, always parentheses, because when you're doing this, these open intervals, when you're doing these increasing, decreasing constant, it's always parentheses. So again, always parentheses. Again, one of the big things people mess up on the test is they throw in brackets here, because we use brackets a lot when we're doing like domain and range of functions and that kind of stuff, solving inequalities. Because we're talking about these open intervals where you're increasing, decreasing constant. In this situation, this is the one situation where we say brackets, just throw them out the window. We don't use any brackets, because we only talk about what's happening between values. We're not ever including the ends. Let's do one more example of this and then we'll move on. Okay, so here you go. We've got another function. This is a function. It's a weird looking function. We'll talk more about these kinds later. So this function has 2 pieces here. You can see it almost looks like you might be able to draw a vertical line here, and it fails the vertical line test except for this circle here is open. Remember that open circles like that, when we do like graphs and stuff, means that you don't reach the values. This is actually getting really, really close to that point, but never quite touching it. So if you draw a line here, you only touch this one, not here. If you draw a line over here, well then you touch this one, but then this one's done. So you're good. So this does pass the vertical line test. So this is a function. Again, the first thing I want to think about is where is it increasing? Well, it's increasing for this piece, right? This piece right here is increasing, because as you go up to the right, it's increasing. So this range from, again, x values, -4 to 1, -4 to 1, so -4 to 1. Again, going left to right, from -4 to 1. That is where it's increasing. And always, when you're doing an increasing, decreasing constant, it's always parentheses. I don't care that these are filled in circles. That's not going to change these because we're not doing range, we're not doing domain. If I was doing like domain, yeah, you would use a bracket for these two, but since I'm doing where is it increasing, I only think about in between, the middle. The other one we have here is where it's decreasing. Well, where is it decreasing? Well, it's decreasing right here because for this piece, you can see you're going down as you go to the right. So this is a decreasing piece. So if I look between these numbers, this is going down to the right. So between 1 and 3, again, x values, 1 and 3, 1 and 3, it's decreasing. It's going down to the right. Always parentheses. Last piece, where is it? Constant. Well, there is no constant piece, right? None of this is going horizontal, so this one, NA, doesn't apply, or none, whatever you want to say. It just doesn't work. Not all functions have all three. I picked a couple that have more than one, but a lot of functions just do one. They just increase, or they just decrease. You don't have to do more than one. So that's not a rule. There's nothing about saying you have to have more than one thing. Okay, so that's the first thing. You should be able to look at a function from its graph. You should figure out where is it increasing, where is it decreasing, where is it constant. Next thing to talk about is what we call relative maxima. So when you have a function like this, like this one down here, this is a good example, you have a maximum. Well, actually you don't, right? You don't have a maximum because if you look at this arrow, it says that this goes up to infinity. So this line actually goes up forever, so there's no maximum, right? Because it's going off to infinity. But you do notice that there's a peak right here. Like this is a little peak. It's a high point. And again, if this is like your company and this is your profit function, and you're looking at your profits go down and then they go back up, and you say, hey, that's where they hit a high point and then they come back down, you're going to try and get to this point. Like if you can change your sales tactics or cost structure or something like that, and end up right here where the profits are maximized because they're the biggest they can get without this. Maybe you'd want to go this way, but maybe there's a limit to how far you can go this way. Maybe this is impossible or something. So maybe that's the best you can do. Like you have to be past this number or something. So that is a high point. It's an important point to know about. It's something we want. We call that a relative maximum because it's not the highest point in the graph. The highest point in the graph goes off to infinity, but it is a high point. Basically, it should mean that you should be able to make a little window where you kind of look at the values within that window, and it's the highest point in the window. That's what we call a relative maxima. It's a maximum if it's a top. If it's a bottom, like this one, so like this one, again, this is a minimum. It's not the minimum because the minimum, absolute minimum, is down forever. But within this range, it's the lowest value. You can find a point that's the lowest value within a range. That is a relative minimum. So we call this one a maximum, that one a minimum. And those are important points to know about. Again, you want to know when your profit's going to be the worst or it's the best. So you want to know about those points. So we call this one a relative max. And this one would be a relative min. Now, there are techniques for finding these from equations and stuff, but they are calculus techniques, and this is not calculus class. So we're not going to worry about those techniques. All I'm going to really worry about for you guys is if you have a graph like this, or if you can get the graph on your calculator, you should just be able to graph it, look at the graph, and find those relative maxes or mins. So like this way, you should be able to see that the relative max happens at 2, and the relative max is 4. So the relative max is 4, because that's how tall it is, and that happens at 2, or you could think of the point 2, 4. Now I'm putting all three numbers, 3 versions of this, because I've seen all 3 versions of questions on algebra tests. I've seen times when they ask, what is the max? Well, this is the max, right? That is the max. 4 is the max, because it's 4 is as high as it gets, right? But sometimes they ask, where does the max happen? Well, this is where it happens, because it happens over here at 2 is where you get your max. You put in 2 and you get your max. A lot of times you want to know what number do I have to get to on the x direction to get the max. And then sometimes they'll ask what the point of the max is, and this is the coordinate. So be careful. Just look and see which one are they asking for. Are they asking for the max value, the highest point, in that range, or where it happens, or what the coordinate is? Which one are they looking for? Relative min, again, same thing. We're going to look at that and say, what is the minimum? Well, the minimum here is actually 0, right? That's the height. So it is 0 as the minimum. That's the lowest it gets in this range. It happens at -2. So at -2, that's the where. Where does it happen? Well, it happens -2 over. And again, this point would be the point over -2, up and down 0. So -2, 0 would be the point or the coordinate. So if you have a graph, you should be able to look at that and see what your relative maxes and your relative mins are. Now, sometimes instead of giving you a graph, they might just give you an equation. And I did show the graph here, but that's because I wanted to print it on here. But they might just give you the equation like this and just expect you to type in your calculator. So I'm just going to type this one in the calculator. So I'll type in this 2x to the third minus 15x squared. Oops. And this is what I get for my, I'm so used to my old calculator still, even though I've used this one for like 4 or 5 years now. I still try to do this wrong, where I do the power and then forget to get out of the power. I always have to use that right button to get out of the power on mine. Not all the calculators do that, but some of them do. Okay, 15x squared plus 24x plus 19. Okay, so there we go. We got 2x cubed minus 15x squared plus 24x plus 19. Check to make sure that's in. I'm going to hit graph. You'll graph it, and you'll see that the graph is not very helpful because it doesn't even show the max, right? You can see the max is going to be way up here because it kind of goes up and down. So a lot of times with something like this, you do have to zoom it. So you can hit the zoom button. You can zoom in, zoom out. Those are 2 options you could do. If you want to zoom out so you can see more, you hit enter. Now it doesn't zoom out. It doesn't do anything. You're like, wait, is it broken? No. What it does is it actually lets you decide where to center when you zoom out. So if like you put your mouse over here, your cursor, so I went up and to the right a little bit. Now when I hit enter, it's going to actually recenter, so that's going to be the middle of the graph. And so you can see how it's like shifted down and over a little bit. And then I graphed it, now I can see the whole thing. But that zoom is not that great, because now I can see the whole thing, but it's kind of still hard to figure out what's going on. I hit my trace key and I can kind of get close to my values. It's not great, which is why sometimes you might see people give you stuff like this. These are the window dimensions. The first part is for the x's, and the second part is for the y's. And so you can actually hit this window button right here, this window button, and you can actually set the calculator's dimensions. How far left and right do you want to go? How far up and down? So here they tell us to go to -2. So I'm going to type -2. Make sure you're using the negative button down here, not the minus. So -2, hit enter. I'm going to do 7. This is how far left and right it goes, because the x is left and right. So -2 to the left, 7 to the right. The 1 is the scale. That's what it counts by. So you can see here it's counting by ones. That's what we're going to do. We're actually trying to make the graph look just like this. The y, we're going to go down to -40. So we're actually go a lot further down the y's. The max, we're going to go all the way up to 80 for the y's. And for the y's, we're going to count by 20. Since we're going from 40 to 80, we're going to count by 20s instead of just by ones. Okay, now we hit graph. Now you can see the graph looks just like this one, basically, because we changed the window dimensions. So this is something that's nice to be able to do. Like if you look at your graph and you say, I just want it to go higher, you can just go in the window dimensions and set the max height, higher. We set it to 80, so it went up way higher. We can see more of the graph. If you just want to make the graph go lower or whatever, stuff like that, you can change it. This one maybe I say, oh, I don't need to go down to -40. I'm just going to go down to -20 and then graph it. And then you can see, oh yeah, now I can see more of this stuff because I really didn't need to see the bottom part or whatever. So you can change the dimensions as you want. And this is just showing you that, like how you can use that information and change the dimensions. Okay, now we still need to find the max and the min from this. So I'm going to use the trace key. You can get close to the top here. And you might be able to look at that and kind of figure out what it is. Oh, yeah, that actually looked really good, right? We got lucky there. It goes 130. So there it is. That's easy. If you can do that on your calculator, happy day, life is easy. So you can see, yeah, that point is 130. And that is a relative max, right? So that's the relative max, 130. And again, if they want, what is the max? Well, it's 30. Where's the max? It's at 1. And this is the coordinate of the max. Now, let's see. Could we do the same thing with the min? So I'm going to go over here to the minimum. See if I can get that. Oh, I can. So that's life easy right there. Now, that doesn't always happen. So just in case that doesn't happen, I want to show you something. If you're trying to find the max and the min, and you can't find it because you're getting decimals and it's getting hard to get, there is actually a tool in your calculator that will find the max and the min. So if you hit second and calc, so this little calc button right here, up there, second calc, there is a minimum and a maximum, and it's built for finding these minimums and maximums. So I'm going to go ahead and do the minimum first because that's where my cursor was. So we're at the minimum. And so what you do is you take your cursor, and first it wants a left bound. So left bound, it just wants you to put your cursor on the left side of the minimum, because your calculator is dumb, right? It's not smart. It's just a machine. And so if you told it to look at this entire line for the minimum, it would keep looking further and further left, and it would never find it. So it wants you to tell it where to look. So we're just going to tell left bound, right bound. We're going to tell it what range to look in. So we put the cursor to the left of the minimum, hit enter, and it'll put a little line here showing you, okay, that's it. I'm not going to look any further than that. I'm not going to look over here for a minimum. And then we're going to go to the right side and tell it where to stop on the right side. It doesn't really matter how close you are to the minimum. You can get close or you can get far away. You just want to make sure you're on the right side for the right bound and the left side for the left bound. If you switch those around, that could be bad. Okay, so I put it there. So now it's only looking in this middle range. Last thing is going to have you put a guess in. Again, the guess doesn't have to be perfect. I'm going to intentionally put a little bit to the side. It just has to be kind of close. Hit enter, and your calculator will figure out what the minimum is. Now, I know it gives you 3.9999, and you're like, oh, that's the answer? No, just round it to the nearest number, right? That's 3.9999, so it rounds to 4, and that's what we got, right? We said that the, oh, I put that in backwards, didn't I? Whoops. That's a good thing we had the calculator do this, so it's actually 4.3. Whoops. I didn't write it down here at least, so we can have it right there. Yeah, it's 4.3. Said that wrong. So 4.3 is the minimum. It's 4 over and up 3. And again, that's what they got here. So they got that. So if you can't just read it off the graph using the trace key, again, you hit second calc, and then you can do that max min. So like if I want to do the maximum, I do the maximum. I come over, first off, I want to do left of the maximum. I think I hit the wrong button. Second calc, maximum. Yep, okay. I had the wrong button. Second calc, okay, so I went left bound, I hit enter, do the right bound, hit enter, my guess, it's somewhere in the middle, hit enter, and there you go. You get about 0.9999 or 1 and 30, just like we got here, 1 and 30. So that's how you can use your calculator to get that. And again, I'm not going to worry about doing any more than that. You should be able to look at a graph, or you should be able to like put the equation in your calculator and look at the graph, and then you should be able to figure out the maximum. That's it. That's all we're doing for maximum. Okay, so that's enough for properties. I told you I was going to introduce what we call piecewise functions. So piecewise functions, the last thing we're going to cover here, just introduce what is a piecewise function. So piecewise function is when you take several functions, you take pieces of those, that's why it's called piecewise, pieces of other functions, and you combine them to make a new function. So like my piecewise function here has 3 pieces, so it has 3 pieces, and each one of these equations gives you a piece. Like this first equation, negative x minus 2, is talking about this piece right here. Because you see it has a negative slope, right? So if you think about this as being like an mx plus b, y equals mx plus b, well their m slope is going to be negative 1. And it's going to cross at negative 2, and that would be that first piece. The second one here, you got negative 2, that's going to be a horizontal line. Remember when you have y equals a number, it's always a horizontal line. So negative 2 is just how high it is. Last piece is 1/2 x, so that's a positive slope. And if you look, this one, if you extend it eventually down, it would cross here at 1. So that would be its intercept. So each one of these pieces is described by one of these equations. But we don't use the whole line, right? I'm not using the entire line, negative x minus 2. So the second part here actually tells you where to use that. So it says, okay, use the first piece for any values less than or equal to 0. So you can see this first line goes until we hit 0, x is 0, and then stops. It doesn't keep going. So let's use the second line from 0 to 2. Include the 2, but don't include the 0. Remember the equals here says include. So from 0 to 2, we've got this line. It's a little confusing, but this open circle is the part of the 0, and then this filled in circle is the 2. So it's a bar like this with a filled in circle here and an open circle there. Last piece is from 2 to infinity, so everything bigger than 2. And so that's why we're using it for here. And then when we get to 2, it says it's not equal, put an open circle. So that's what this is. This is the function using these 3 equations for those values. So for values of x less than or equal to 0, we're using the first one. Between 0 and 2, we're using the second one. And for values bigger than 2, we're using the last one. Now, because this is a function, we can talk about domain and range. Remember, we said domain is the horizontal, the x values. So always think about x's. When you do domain, how far left and right does this reach? Well, you can see the line goes forever to the left, right? So it's going to go forever this way. It goes forever to the right, and everything in between is covered, right? Even this point's covered. That point's covered. These points are covered. So everything from negative to infinity. So the domain for this is negative infinity to infinity. Now, you don't have to have that be true for piecewise. I could just slide this piece over to the right, start it at 4 instead of 2 or something like that. So it starts here, and there'd be a gap. And you can have gaps in piecewise functions. But your textbook's pretty nice. I think every piecewise function they pick is going to not have really any gaps. So that's probably not going to be something you see very often in this homework for this class. Okay, range. Remember range? It's the y values. It's how far up and down it goes. So the range for this one you'll notice there's nothing below negative 2. So anything below negative 2, there's nothing there. So it actually starts at negative 2. So the range is going to be from negative 2, starting at negative 2, going up. You notice that this piece goes up forever. The range is going to go to infinity. Now, of course, I always use parentheses for infinity. And for the negative 2, because we actually have values down here, we reached negative 2, we're going to use the bracket. We're done with that increasing, decreasing now. We're working on range. So now we have to go back to using brackets. We can't just skip them anymore. So you only get to skip the brackets when you're doing that increasing, decreasing constant. So that's just the range and the domain of this function. Again, it goes left and right forever. From up and down, it goes up forever, but it stops at negative 2. Okay. Now one of the big things we do with functions, right, is we plug numbers in, and then we get a result out. So we're going to do that with the piecewise function. So this piecewise function, this is a new one, has 3 parts. It's got 4 is the first part, negative 1/2 x plus 3 is the second part, and negative x plus 2 is the last part. We want to evaluate. So when they give us, this is supposed to be called h. Oh no, I messed that up in my notes. Okay, this is supposed to be function h because we're evaluating function h. I don't know why I didn't get that fixed. Okay, so here we're going to plug in negative 4. Remember, this is telling us what x is. Plug in x into the function, and then get an answer. The problem is we don't know which one of these 3 pieces to use. Well, actually we do, because when they tell us what negative 4 to plug in, what x is, they're telling us what x is, they're telling us how to figure out which one to use. So when they say plug in negative 4, they're telling us to make x equal negative 4. Well, if x is negative 4, then which one of these is true? Is negative 4 bigger than 2? No. Is negative 4 between negative 2 and 1? Nope. Is negative 4 less than negative 2? Yes, it is. So x is less than negative 2, because negative 4 is less than negative 2. So we're going to use this first one, we're going to use the 4 function, the 4 part of the function. So this one says that whatever value you plug in, this one always gives you the answer 4, because there's no x to change things. So this one gives us the answer 4. So that's what we're looking for. If I give you h of negative 4, I want you to plug in negative 4. Well, I want you to look and say, okay, if I make x negative 4, which one of these is true? Negative 4 is less than negative 2, so I use this function to answer my question. So I did that first one, I'll do that one in blue. So if I have any more of those, I'll do them in blue. But that's the idea. So that's our blue one. Okay, next one I have 0. So 0 is not less than negative 2. It's not bigger than 2. It's 0 is between 1 and negative 2. So for this one, h is 0, x is 0. We're going to say, well, 0 is going to be between 1 and negative 2, right? 0 is less than 1 and bigger than or equal to negative 2. So we're going to use the negative 1/2 x plus 3. That's the piece we're going to use this time. So if I put 0 in there, I get h of 0 is going to give me negative 1/2 of 0 plus 3. So we're plugging 0 into the function. Well, that 0 times 1/2, that's just going to cancel and become nothing. So we just get 3. So h of 0 is 3. So we use the middle function. We use this one because 0 is between negative 2 and 1. So that's how we knew which piece to use. We use the middle piece because 0 fit between these two numbers. Okay, let's try the next one. 5. Well, 5 is bigger than 2. So for this next one, we're going to do 5 as x. So x is 5. And that means that we're going to have x be bigger than 2 because 5 is bigger than 2. So we're going to use the last piece, this negative x plus 2. Negative x plus 2. So that's what that looks like. So this last piece here is what we get. So we get negative x plus 2. So to find h of 5, we're going to plug 5 in for x. So we get negative 5 plus 2. Well, negative 5 plus 2 is negative 3. So that's what we get for that piece. We get negative 3. Try one more. Now at this point, you should be able to figure it out. You look at that, you see negative 2. You should be able to know which one it is. So negative 2. It's not bigger than 2. It's not less than negative 2 because it is negative 2. It's equal to negative 2. So this would be another version of the middle one. So this one, x is negative 2. X equals negative 2. So negative 2 is less than or equal to negative 2. Rx. So negative 2 is between 1 and negative 2 if you include negative 2. So we're going to use the middle one again. We use the negative 1/2 x plus 3 to find that h of negative 2. So I'm going to plug negative 2 in here, so I get negative 1/2 times negative 2 plus 3. Multiplying the negative times negative gives us a positive. A half times 2 is 1, right? Half of 2 is 1. And then plus 3 more, this gives us 4. Right? So we get 4 for that. So h of negative 2 is a 4. And you can graph these, right? Because this is a function, so every time you plug a number in for x, you get a number out for y. That is a point on your function. So like this first point, at negative 4, we get 4. There's a point right there. On the second part, we have at 0, we get 3. There's a point right there. For the third one, at 5, we get negative 3. So 5, we get negative 3. And then the last one here, we said at negative 2, we get 4. So at negative 2, we get 4. And you can see, the first piece, because that's the stuff less than negative 2, is right there. The middle piece, negative 2 to 1. And then the last piece for stuff bigger than 2. So it's all, in the right locations. We'll deal more with graphing on the next page, so I'm not going to finish graphing this. But you can actually fill this in pretty easily. You just look at things like the 4 is a constant function, so it's going to be horizontal, and it goes until you hit negative 2. So it's going to be like this, and then you hit negative 2, you put an open circle. Maybe I'll just graph it because I'm started already. This one's going to be a fraction that goes negative slopes, goes down to the right, crosses at 3 right there, and it goes until you hit 1. So it would stop here. So if I go down 1 over 2, that's what this is. Down 1 over 2 is too far, so I'm going to stop about halfway. So I'm going to probably be about here. But that's going to be a open circle because we don't actually have value there. So it'll be like this. It's filled in here because we have a value at negative 2. Last piece here, this is going to be negative x plus 2, so it's going to go down to the right. Negative slope, negative 1, so this is negative 1 over 1, so it's going to be like this. And it's going to stop at 2, so at 2. So if I go back 1, up 1 over 1, eventually I'd have a point here, and that'd be equal. So this last piece is going to look like this. So that's what these look like. This negative x plus 2 is this piece. This negative 1/2 x plus 3 is this piece, and this 4 is this piece. And again, we're stopping where they tell us because, that's what these say. They say, just go until you hit negative 2. Go between negative 2 and 1, and go for numbers bigger than 2. This one actually has a gap here. So if you did the domain for this one, there'd actually be a little gap in the domain. You have two pieces. You have the left piece and the right piece with a little gap in the middle. So I said, you're not really going to see that in the homework so much. This one we just use for valuing really, but that's what it would look like if you graphed it. Now the problem with these, you can't just graph them nicely on a calculator. You can't just type this whole thing. You can graph the parts. So I could type in like 4 on here and see what it looks like and see that that's what. Oh, I've got to rezoom this. I'm going to hit zoom 6 because that's a nice standard zoom. So you can see where it's going to cross here at 4 with the graph. I'm still thinking. Did something to it. Now it's thinking too long. Okay. Give it one more minute and I'll give up on it. There it goes. So it'd be like that one piece, but we know we're only using part of that, right? We're not using the whole line because it stops at negative 2. So that's the idea. You can graph pieces of this. I could graph the last piece, the negative x plus 2 piece. I could graph that and see there's a piece that would be over here, this end. But again, it graphs the whole thing, not just the piece I want, because it's difficult to tell it to where to stop. So we're just gonna, with doing this kind of stuff, graphing and all that, you can use your calculator to get an idea about what the pieces kind of look like, but trying to get the exact piece is not so easy. Okay, a couple more pages. Let's do one more evaluation problem page. This is something people really struggle with because they have a hard time remembering how to evaluate. So I'm going to do one more of these, and then we'll, I think, graph the last one, and then we'll probably be done. Okay, so here I went function f. This time I have the right letter. I want to plug in negative 3. So again, that's my x. So the negative 3 is my x. So negative 3 in this case is not bigger than 0. It's not less than negative 3. It's equal to negative 3. So since negative 3 is equal to negative 3, this less than or equal says equals okay. Then we're going to use the negative x part. So we're using the negative x because we're in the middle. So that's what this one's telling us. Because we're in x is negative 3, we're in the middle. So to find f of negative 3, we're just plugging negative 3 into this. So we're getting negative x. So now that x becomes a negative 3, so we get double negative. Remember that a double negative always makes a positive, so this just becomes 3. So 3 is the answer for that one. Try the next one. I want to do f of 0. Well, 0 is equal to 0, so this will be the last one. I'll do this in green. So this is x is 0, and 0 is greater than or equal to 0. So we're going to use the last part, we're going to use the 2x minus 1. So to do f of 0, I'm going to plug 0 in there, so I have 2 times 0 minus 1. But 0 times anything, still 0. So this becomes negative 1. So it's negative 1. Okay, next one, got 2. But 2 is actually also bigger than 0. So this one's actually the same as the last one. It's the same, x is 2. Well, x is 2 is bigger than 0 because bigger than is okay. Equal or bigger than is okay. So we're actually going to use that 2x minus 1 again. Trying to trick you there. I bet you thought we were going to use the top one, but we actually are using the bottom one again. So f of 2 is going to be 2 times, well, x is 2, so 2 minus 1. 2 is 4 minus 1 gives us 3. So this one, the answer is 3. Last one here, I got negative 5, and yes, that is less than negative 3. So this last one I'll do in red. Oops, is going to be that one right there. Okay, so we're going to, because x is negative 5, and negative 5 is less than negative 3. We're going to use the first one, which this is a constant function again. This is just a number. Anytime you get a number like that, it just means that whatever you plug in, the answer is always that same number. So h of negative 5 is just 0. There's no x's to change, so it gives us 0. Again, constant functions, that'll just give you the result. So that's evaluating. I'm not going to worry about graphing this one too because we already graphed one. So the last page I have here, I'm pretty sure, is about graphing. So let's do one where we just have to graph. They don't tell us to evaluate anything. They just tell us to graph. So we'll go ahead and graph this one. Let's start off. We'll do the first piece in blue. Now notice that this piece is only going until you hit negative 1. We're not going to go past this negative 1, so it's just for values out here. Now to get this graph, there's a few things I can do. One thing is I can just pick any numbers I want out here, and I can plug them in. So if I want to, I could do something like f of negative 2, because that's a value that's in this range, and f of negative 2 is less than negative 1. So I could plug that in and use this first piece. So I get negative x, which is negative 2, plus 1. A double negative again, to negative makes a positive. So 2 plus 1, I get 3. So I know that negative 2, I get 3. And that's going to be a point on this function. And I could keep plugging points in. I could do negative 3, negative 4, and I get many more values. Or I can look at this function and I can remember that y equals mx plus b. Remember my slope and my intercept. And this one I can see the slope is negative 1. So as I go to the right, it's going down 1 over 1. So I should have a point right here. And I do get to actually put a point that's filled in, because this is equals, right? So I'm actually going to go all the way to negative 1. I'm not going to keep going, though, because negative 1 is where I stop. So it's going to stop here. As you go to the left, it goes on forever, so you can see that if I go backwards and just follow my 2 points, because 2 points is enough to make a straight line, it looks like that. So that would be the first piece. Let's look at the second piece. For the second piece, it just could be the function 2 for all values from negative 1 to 3. So from negative 1 to 3, so in this range, I'm always going to have a 2. So this function is going to be 2 for all these values in between. So like at 0, it's going to be 2. At 1, it's going to be 2. At 2, it's going to be 2. Everything in between, like 0.5, it's going to be 2. 1.5, that's going to be 2. Because we're looking at the values between 0 and 3 as always being 2. Now, one thing I'm going to look at with this is what happens at the ends. Notice that both of these are not equal to. So at the ends, it's going to be open circles. So at both ends, it's going to get close to, but not quite touch. So it's going to look kind of like that, almost like a barbell with 2 weights on the ends. That's what it's going to look like because it's open because there's no equal to. Last piece, let's do this 3x minus 6. And this again is only from 3 on. So from 3 on, we're going to the right. That's going to be this last piece. Now again, if I want to kind of get some points, maybe I'll plug something in. Like I might do f of 4 just to see what happens at 4. That might help me out. So I'm going to do 3 times 4 minus 6 and see what happens. Well, I get 3 times 4 is 12. Minus 6 gives us 6. So you can see at 4, we get 6. So that's going to be there, what it's doing. Notice that 3x, that means it's going up to the right. So if I go over 1, I'm going to go up 3 over 1. It's going to be like way up here. So it's going to be kind of going like this, shooting off. If I go backwards, I would go down 3 and back 1. I'm doing the opposite. It would be here, and because it's equal to, it actually does have a value there. If I wanted to, I could plug 3 into this as well and do 3 times 3 is 9 minus 6 and get 3. And that would be that point. So you can see this one's kind of going like this. I kind of had the point off a little bit. So it's going to be like that. And that would be the graph of this function. So we graphed it, so now we can see what it looks like. Again, you can graph each one of these pieces in your calculator. You can graph this line or this line or this line in your calculator, but it's going to graph the entire line, not just the piece we want. So you got to really pay attention to these cutoffs. Where does it stop? Okay, for this, let's talk about domain and range. Again, domain is how far left and right it goes. Domain is your x's, right? Your x values, how far left and right. Well, it goes left forever, it goes right forever. Everything's covered. There's no gaps in here. So this domain is still negative to infinity. I told you, they'll kind of tend to stick with that for these piecewise functions. They're not trying to make things super difficult. I know sometimes we do that math without trying, but they're trying not to. So they're going to probably keep that mostly pretty straightforward with these domains. Range, again, is the y's. So now range, I'm looking for up and down. Again, this one stops. It doesn't keep going down forever. So it stops here. This time it stops at 2. So the bottom of this one's going to be 2. But then it goes up forever. Like this piece goes up forever, or that piece goes up forever. So it goes up forever. So the top end of the range is going to be infinity. And that's going to be your range should be a bracket because we actually reach 2. Again, we're back to brackets because we're done with those increasing, decreasing constant. Now we're talking about real range, how far up and down it goes. Okay, now there's one more special type of piecewise function. This is something your book talks about a little bit. It's kind of a special piecewise function. I'm not going to test you over this, so I don't expect to see this one in the exams or anything. I just wanted to help you out with it when you got to the homework. So this is called the greatest integer function. And what it does, it's a function that just outputs the biggest integer that's still less than or equal to the number that's put in. So greatest integer less than or equal to the input. And we use this notation right here. So you'll see the greatest integer function look like a couple brackets around the number. So this greatest integer, remember the integers are either positive or negative whole numbers. So we're looking for the biggest whole number that's still less than or equal to the number. So we want to go past it, but we don't want to go above it. We want to get the biggest number that's still the same amount or less. So like for the first example, what's the biggest number that's less than 2.5? Well, 2, right? So this one, the answer is 2. So if you think about this, the stair-step function, you can see how if you go to 2.5, the answer is 2, right? That's where that 2.5, that's giving us the height 2. So anything between 2 and 3 is going to give us a 2. If I do negative 1.45, now this one's kind of tricky because you might be thinking negative 1, but it's actually negative 2, because if you go negative 1.45, you're actually over here, so you have to go all the way down to negative 2, because negative 1 is actually higher than negative 1.45. So that one's actually negative 2. So that's what that is. 3, it's okay for them to be equal, so 3 just gives us a 3. So this one's 3. Last one I have here, I have 0.078. Since this one is less than 1, the biggest integer we can get is 0. So you can see if I go 0.78, I'd be like right, 0.78, it's going to be like right here. And that is 0. It's 0 height. It's right on the 0. That's why this one's 0. So that's the greatest integer function. It's just looking for the biggest nice whole number or negative number that's still smaller than or equal to your number. I don't want to go past it. I don't want to go above 2.5. I don't want to go above negative 1.5. So I have to stay below it. That's what the greatest integer function is. Okay, so that's it for this section. So just kind of going over some properties of these functions, how we talk about the increasing, decreasing constant, the relative maxima, and then introducing the idea of piecewise functions. We won't see a ton of piecewise functions come up throughout the rest of the semester, but they do come up a lot in real life. There's lots of situations where a function will have different parts, different pieces, be made up of different parts. So that's why they definitely cover it in this class. So it's something you might see in the future. You might see it on a graph in like a journal or a textbook. But that's probably where you'll see that come up. We won't see it a lot more in this class. We will talk about increasing, decreasing parts of functions. That will definitely come back later. That's it for outcome 7. We'll see you on the next set.